one of the coolest applications of conditionals is recursive functions. So a classic example is the factorial symbol in math. So 3 factorial evaluates to 6 as 3 times 2 times 1. Similarly, 2 factorial is 2 times 1. 1 factorial is just 1. And 0 factorial is actually defined as 1. So what we're going to do is we're going to write a function to sort of deliver the factorial in math. Now, go ahead and open a new Colab notebook and let's title it recursive functions and let's get started. Let's call this def factorial, and the input's certainly going to be a number. Now, this is tricky to code sort of directly because the numbers of terms that you need to multiply varies depending on the number. And it's not to say that you can't do it directly, but doing it recursively is really cool. And so to understand like what recursion actually means, let's sort of rewrite these factorials above or look at them in terms of the following. Well, 3 factorial is 3 times 2 factorial, right? Similarly, 2 factorial is 2 times 1 factorial. And even in this case, 1 factorial is 1 times 0 factorial. Okay, so the idea here is that 3 factorial is 3 times 2 times 1, but you can get that from sort of doing the factorial thing again and again and again, and that's how recursion works. Okay, so what we need to start with is a way that the function is actually going to end. And if the number is equivalent to 0, I think it's unambiguous that we just return 1. Okay, that is by mathematical definition. Now, what about in the other cases? What do we do? Well, let's just take 3 factorial as an example. The idea is that we want to return, okay, and we're just going to return it, bear with me, the number, which in this case would be 3, times what? Times the factorial. So we're calling the function within itself. That's the whole idea of recursion. We're calling it the factorial of the number minus 1. Okay? So again, let's look at 3 as an example. So if we put 3 in here, it's going to be 3 times factorial of 2. Well, what do we do for factorial of 2? I'll write it out for you. Okay? So if we put 3 factorial into our function, okay, what happens? All right, so we get 3 times 2 factorial. Yes, since I'm going to do this in multiple lines, let's make the triple quote the multi-line string. Okay, and then, 3 times 2 factorial, but 2 factorial is in fact what? Well, if you look at the code, I'm not looking at the definition, I'm looking at the code. That'll be, well, it says to multiply 2 by the factorial of 1. And I guess for notation, I guess maybe it's a little cleaner to call it like this. Because, it's times factorial of 2. Okay, this symbol is nice to use. And then you can keep going. What's factorial of 1? Well, now that's 3 times 2 times factorial of 1 is going to be 1 times the factorial of 0, right? And in conclusion, that's going to be 3 times 2 times 1. We have this extra times 1 because of this special condition. Okay, so that's why it works. It's kind of beautiful. I think understanding the idea of recursion is sort of the main thing here. It says incomplete input because I did not close my multi-line string. Good job, Colab, for catching that. Because it's showing the string here. Let me just take it out. That's why it's going to be better as a comment. Or I can just store it as a variable. Command Z works inside of Colab. And so basically it's a sample code because I don't want it really to show up. And now it should be okay. Okay, so I want to call now factorial, say, of 3 because it should evaluate to 6. Ta-dam! It works. Beautiful. You can check the factorial of 4. That's 4 times factorial of 3. That's the whole point. It should be 24. And finally, factorial of 5. You get the 120. You can even check a big number. These can quickly get big, right? Like, what's the factorial of 25? I have no idea. Well, look how quickly it got that gargantuan number. Pretty impressive. So, and the idea of recursion is that it calls itself basically 25 times to do it.